Hey everyone, this is Matt. Today I'm going to talk about another um, problems on Leet code. It's linked list cycle number two. So the first linked list cycle I just recorded 1 hour ago. This is just a follow up for that question. So this question is a little bit harder because rather than ask you to check if a linked list has a cycle in it or not, but this question is ask asking you to return a pointer which points to the first node um, in the linked list that where the cycle begins. So let me give you an example. So if we have a circle like A, B, C, D, E, and C. Okay, so there is a circle in this linked list, which is C, D, E, and then it goes back to C. Okay, so the beginning of this circle is C, because after E, it goes back to C. And A and B um, is the nodes from the at the beginning of this linked list. So start from C, the cycle begins. So this problems is asking you to return this kind of to return the location of this node if the linked list has a cycle in it. If the linked list does not contain a cycle in in it, you only need to return a non-value, which means there is no such location, there is no such pointer. Okay, so the following C++ code is the solution. Let's look at it in details. Similar to the uh, previous solution, linked list number one, you first need to check if the head is a long value or not. If it's a long value, there is no cycle, so you just return none. And we also need to define two pointers. First one is fast. The second pointer is slow. And at the beginning, they both point to the head of the linked list. Okay, and in this solution, we have two while loop. The first while loop, you can see it's pretty much the same as the previous solution. In the previous solution, we also have the same code, and these few lines of code is to uh, check if there is a cycle in the linked list. So when we have two pointers, and the first pointers walks forward two steps at each iteration, and the slow pointer um, walks forward just one step at each iteration. So the fast pointers just walks faster on the slow pointer. by one step each iteration. So if there is a cycle in this linked list, the condition in the first while loop will never be satisfied. So they will never stop. If there is no cycle in the linked list, these two conditions will one of the conditions. So one of the pointer will become will be non-value because after you update the first pointer, it will finally reach to the end of the linked list. But if you have if the linked list has a cycle, then they will go back to the beginning of the cycle pointer. So these two will always these two conditions will always be true. Okay, and so the first few lines of code just to check if there is a cycle in the linked list or not. And once we find there is a cycle, okay, the second while loop is a trick. So you update the slow pointer point to the head of the linked list. Remember, when at the first while loop, when you find that fast equal to the slow pointer, that which means they meet at some at a certain positions in the cycle, and then what you need to do is you update the slow pointer or fast pointer, whatever you want to, or you can assign a new pointer point to the head of the linked list, and you update the pointer that points to the head one step each iteration, and you updated another pointer which points to the positions that these two pointers meet in the cycle in the first while loop. So you update these two pointers. To make it clear, you have to remember the first pointer is the pointer points to the head of the linked list, and then the second pointer is points to the positions these two fast and slow pointers meet in the cycle. So you update those two these two pointers one step each iteration, and they will finally meet at the beginning of the cycle. So in this example, the second the slow pointer and the fast pointer, they will finally meet at the node C. So here you update snow to the head of the linked list, which is A, and assume at the first while loop these two pointers meets at E. Okay, and so you update. So in the second while loop, the snow start from A and the fast start from E, and they update and and they walks forward one step each iteration, and they will finally meet at C. So this is this is what this solution does. Um, but if you want to understand the mathematical analysis behind this code, I think you should search some article on Google, so you can understand the um, mathematical explanation behind this. Okay, this is the solution. Hope you like it. See you next time. Bye.